Section 3.4 is graphing rational functions, and we did a lot of work in this area last time. We didn't do the actual graphing, but we did a lot of the steps, as you'll see. Because here come the steps. Step 1, factor the function. We've been doing that for years. Step 2, find the vertical asymptote, or totes. We did that last time. Find the horizontal asymptote. Did it last time. Find x-intercepts. We did that last time. Find y-intercept. Did that last time. Find points of discontinuity, which are also called holes in the graph. Did that last time. Step 7 we didn't do. Make a table of values. When you make a table of values, you want to choose some values which are very close to the vertical asymptote, or asymptotes. You want to choose x of one very, very large positive number as an x value, and you want to choose one very, very large negative number. When I say very large negative number, I mean like -1,000,000 or -100,000 or something like that. And the last step, you're then going to connect the points with a smooth curve, and you'll be done. Okay, let's do 3 of them. Look at all these steps. So the first thing we want to do is find I want to factor. So let's go ahead and do that. Factor this. We get y equals, you can factor the top. It's a simple trinomial one. So 2 numbers that multiply to 8 and subtract to 2. That's x plus 4 and x minus 2. On the bottom, you can factor out a negative. Why would we bother doing that? Because once you factor out the negative, you're left with x plus 4 in the bracket. And that's good news because we can cross those out. Now, we had common factor in the numerator and denominator, which we crossed out. What does that mean is going to show up? We're going to have a point of discontinuity. We're going to have a hole in the graph. All right, let's find the vertical asymptote. So the new function, I guess, simplified function, is y equals x minus 2 over negative. Well, why don't we just move the negative up? Negative x minus 2, or let's expand this. It'll be easier to graph. Negative x plus 2. This is a linear function. It's going to be easy to graph in this form because you know what your slope and your y-intercept is. Alright, let's find the vertical asymptote. It actually turns out that when it's this basic, this linear function, you probably don't need to do any of this other stuff. You can probably just go right to the graphing. But we'll do it anyway. What the heck? Vertical asymptote. That is where the denominator is equal to 0. What's our denominator here? 1. Well, that's never going to equal 0. So in other words, none. We don't have a vertical asymptote. Horizontal asymptote. Remember how we do that? We look at the degrees. The degree of the numerator is 2, and the degree of the denominator is 1. So we have the top one bigger than the bottom one. Remember what that means? That means there's no horizontal asymptote either. None. Y-intercept. To get the y-intercept, we set x equal to 0. So we get -0 plus 2, which is 2. Our y-intercept is at 0, 2. Our x-intercept. To get the x-intercept, we set the whole thing equal to 0. So we get 0 equals -x plus 2. Let's move the x over. You get x equals 2. So our x-intercept is 2, 0. Is that everything? The hole. Do we have a hole in this graph? Yes, we do. Where do we have the hole? We have the hole at this point here that we crossed out. What's the non-permissible value there? -4. So the hole's at -4. How do we get the y value? Plug it into this simplified equation. So -4 plus 2 is equal to 6. So we have a hole in the graph, a point of discontinuity at -4, 6. Alright, let's put that in first, our point of discontinuity. So -4, 6, we have a circle, and then we have a y-intercept of 0, 2, and a x-intercept of 2, 0. Or of course the other way you could do this, you could say, oh, we have a y-intercept of 2, you knew that right away here, and a slope of -1, which is the same as down 1 over 1, down 1 over 1. Oh yes, it's just a line that looks like this. So we can draw our line, but make sure that you don't go all the way up. Right? It doesn't go through that circle there. So we'll throw some arrows on the end of that, and that is our graph right there. It's just a linear function, but there's no point right here. Why is there no point right there? Because if you plug -4 into the denominator here, you end up with a denominator of 0. You can never have a denominator of 0. Okay, the next one I'll factor up top here to save some space. So we have y equals x plus 2 over x plus 2, x minus 2. Hey, what do you know? We got a common factor again on the top and the bottom. So we can cross out the x plus 2 and the x plus 2, which leaves us with a simplified factor of 1. There's nothing left up there, but you don't put 0, because then it would be 0 divided by something 0. It's 1. 1 over x minus 2. Okay, here we go. The vertical asymptote. Vertical asymptote is where the denominator equals 0. Well, when does x minus 2 equal 0? When x equals 2. Horizontal asymptote. Take a look at the degrees. This has a degree of 1. Bottom polynomial has a degree of 2. The bottom polynomial is more. That's just like all the ones we did last year. That means the x-intercept is your horizontal asymptote. The equation of the x-intercept is y equals 0. The y-intercepts. To get the y-intercept, put x into put 0 into the x's, so we get 1 over 0 minus 2, which is 1 over negative 2, or negative 1 over 2. What's left? The x-intercept. To get x-intercept, we make the whole thing equal to 0. So 0 equals 1 over x minus 2. Remember, when it's equal to 0, we can just ignore the denominator because we could multiply both sides by x minus 2. 0 times x minus 2 is 0. And this side multiplied by x minus 2, the x minus 2's will cancel out. So you're left with 0 equals 1. What do you say about that? I say not possible, so this means there's none. There's no x-intercept. The hole. Is there a hole in this one? Yes, there is. Where's the hole? The hole is where the non-permissible value we crossed out. Where is that non-permissible value? It's at negative 2. So we have a hole at negative 2. How do we get the y value? Plug it into this simplified function. So 1 over negative 2 take away 2. That's 1 over negative 4, or negative 1/4. Okay, we're good to go. So we have a vertical asymptote at x equals 2. Maybe I'll make a different color. X equals 2. X equals 2. That shouldn't have an arrow on the end of it. Just ignore the arrow on the end. We have a horizontal one and the x-intercept, y equals 0. So that's also an asymptote. We have our y-intercept at negative 1/2. In other words, 0, negative 1/2. So that's 0, negative 1/2 is right there. We have no x-intercept. We have a hole at negative 2 and negative 1/4. So right around there, there's a hole. And that's all we've got. So the next step it says to do is to make a table of values and put some points, put the following points. Put a very, very small negative number, like maybe negative 1,000. Put a number just a little bit below this vertical asymptote. So this vertical asymptote's at 2. Let's use 1.9. You can even do more dramatic here. You could put negative 1,000,000, 1.99 or something like that. The closer you get, the more obvious your answer, like the trend, will be. We also want just on the other side of the asymptote over here. So let's say 2.1. And we want a very big positive number, so let's put 1,000. Now, I don't think I'm going to bore you by taking the calculator out, but basically what I'm doing is I'm plugging all these numbers into this x here. So 1 divided by negative 1,000 take away 2, and when you do that, you're going to get something very, very small, and it's going to be negative. So it's just a little bit smaller than 0. The way we can write that, just to kind of represent it, is 0, negative. It means it's 0, but just a little bit below 0. 1.9, when you put that in, you get very, very close to, you get around negative 10. And when you put 2.1 in, you get around positive 10. You can try these out for yourself. Actually, you do get exactly negative 10 here, and you get exactly positive 10. When you put 1,000 in, you get very, very small number. This time it's positive, so it's 0, a little bit more than 0 this time, so we put 0 positive. Now, what's that telling us? It's telling us that as we go way, way out here, the the graph we know is going to approach the asymptote, but we don't know, is it going to be on the top or is it going to be on the bottom? But it shows us right here that when we go way out here in negative x, it's just a little bit below 0. Oh, that must mean that the graph is very, very close to the asymptote underneath, right? Because it couldn't have crossed it anywhere. And that makes sense because here's our hole in the graph, so it must come, it must come over here to the hole, doesn't go through, or kind of a point of discontinuity, comes through this point, and when we get to 1.9, so that's right around here, we're all the way down to negative 10. So it's coming down, and as you can probably guess, it's going to get closer and closer and closer to this asymptote, but never touch it. So it looks something like that. Now it's going to do the same sort of thing. Let's see, when we have 2.1, just a little bit over here, we're already up at 10, so it's up there. And when we have 1,000 way out here, it's a little bit above, so it's going to be on this side. So we must have another one of these curves coming down here. Now, you could probably do it right away, or maybe you want to, I want to see another point here. I'm going to try 3, because I want one more point for it to go through. I'm going to put 3 in here. So I get 1 over 3 minus 2. 1 over 3 minus 2. That's 1 over 1. Oh, it's 1. Nice. We have the point 3, 1. Okay, I'm feeling pretty good about this now. I'm ready to graph it. It's getting closer and closer, and then it curves out here, smooth curve, and then it goes along here, getting closer and closer like that. And there you go. Looks like the graphs we did last year, except it has the point of discontinuity, and it's moved over. In fact, if you think of it with your transformations, it's exactly the same as last year, except it's moved over 2 to the right. It's been translated 2 steps to the right. And that's exactly what's happening here. If you took our original asymptotes at the x and y axis, moved it over 2 to the right, it's exactly what you have here, plus you have the point of discontinuity. Okay? Don't forget your transformations. Those can also help you. Last one. Start by factoring. So y equals, you can factor out a 2 on the top. That leaves you with x squared plus 1. And on the bottom, you can factor, you get x plus 1, x minus 1. Can we cross anything out here? No. If it's a binomial, it has to be exactly the same binomial. There's nothing we can cross out. In other words, we're not going to have a point of discontinuity in this one. Okay, vertical asymptote. It's where the bottom, the denominator, equals 0. Well, that would happen when x equals negative 1 or x equals positive 1. The horizontal asymptote. We have to look at the degrees of each polynomial. The top polynomial has a degree of 2. The bottom polynomial has a degree of 2 as well. Oh, it's got the same degree. Remember how to find the horizontal asymptote? Take the leading coefficients and divide them. So it's y equals 2 over, what's the leading coefficient here? 1. 2 over 1. In other words, y equals 2 is your horizontal asymptote. Y-intercept. Let's get the y-intercept, put 0 in for the x's. Let's do it in this first one up here. So we get y equals 0 plus 2 is 2, and 0 take away 1 is negative 1. So our y-intercept's at 2 divided by negative 1, or negative 2. 0, negative 2. X-intercept. Got to make the whole thing equal to 0. So 0 equals, let's use this one this time, the factored one. 2x squared plus 1 divided by x plus 1. You can use the first one if you want. You'll just end up, the original factor, you could use that one. You'll just end up factoring again. Since we already factored, we might as well use it. Okay, when it's equal to 0, we can ignore the denominator. So you get 0 equals 2x squared plus 1. You can also ignore that 2 because you could divide both sides by 2. So you're left with x squared plus 1 equals 0. Move the 1 over. You get negative 1 equals x squared. Take the square root, plus or minus square root of negative 1 equals x. Is that possible? No, it can't take the square root of a negative number. In other words, there's no x-intercept. Any holes in this one? No. Why? Because we didn't cancel any factors, so there's none there as well. Okay, we have got a vertical asymptote at negative 1, so right here, and a vertical asymptote at positive 1. Y equals 2. Ignore those arrows again. So those are the asymptotes. We have, what else? We have a y-intercept at 0, negative 2, so down here, and no x-intercepts. That's it. That's all we've got. Wow. That is a long way to go to get our graph here. So let's think of some points you want to use. We want to use a very big negative number. So how about negative 1,000? We want to use, the next point we want to use is a point very close to this asymptote here, and this is at negative 2, so how about negative 2 point, or sorry, this is at negative 1, so how about negative 1.1? And just a little bit on the other side, which would be at negative 0.9. Same here, we want to point on each side of this vertical asymptote, so that would be 0.9 and 1.1. And we want a very big x value, so maybe something like 1,000. Now, what you'll notice is the negatives and the positives should be the same, because what we're doing is we are, wherever you see x, you're squaring it. So whether you have a positive or negative, it's always going to end up being positive. So you actually only need to find 3 of these, and it's going to repeat. This point's going to be the same as this point. The two negative 9s are going to be the same. Negative 0.9s, the two 1.1s will be the same, the two 1,000s will be the same. Again, I'm not going to bore you by showing you my calculator skills. You can throw those numbers into the original function. I think that's easier, or you could plug it in here. It is a bit of a hassle, but it's got to be done, so use your calculator skills. When you put it in here, you should get a number very, very close to 2. It's just a little bit more than 2, so we put 2 plus. Same with here, you get just a little bit more than 2, so 2 plus. When you put it into negative 1.1, you get something around 21. Same when you do it here. And when you put negative 0.9 in there, you get something like negative 19. And negative 19. So let's do that. Negative 1,000, you get just a little bit more than 2. Okay, so it's good. We now know that the curve is on this side of the asymptote, not on the bottom. It's on the top because it's 2 plus. So we know we're basically out here. When we have negative 1.1, we have way up 21. Okay, good. So we know it's going to do some kind of curve like this. Same here when we have 0.9. Oh, sorry. Yeah, we'll do that first. When we have 1.1, it's way up here, and when we go way out to 1,000, it's just a little bit more than 2, so it's like this. So again, this is going to come like that, this is going to come like that. And in between, when we had negative 0.9, it was at negative 19, so it's way down here, and same down here. I think we can already graph in here, can't we? It's going to get closer and closer and closer to this asymptote, and closer and closer and closer to this asymptote. Okay, now we just need to figure out, like, how should I draw this curve? Should I draw it like this? Should I draw it like this? I don't know. We don't have to have it exact, but why don't we find one extra point to kind of help us out? And remember, it's going to be the same on both sides. So how about we try the point 3? If I put 3 in here, I get 3 squared is 9, times 2 is 18, plus 2 is 20, over 3 squared is 9, take away 1 is 8. 20 over 8, which is the same as 2.5. 10 over 2.5. So 3 and 2.5. Ah, that's good. If you want, you could do one more. What the heck? I'll do one more point. I'm going to do 2 as well. If I put 2 in here, I get 2 times 2 is 4 times another, or 2 squared is 4 times 2 is 8, plus 2 is 10. And 2 squared is 4, take away 1 is 3. So I get 3 and a third, 3.3 repeating. So when it's at 2, it's at 3 and a third. It's about like that. Hey, I feel good about this now. It's going to come very close to the asymptote up there. It's going to curve out, smooth curve, and it's going to go like that. We should have the same thing on this side, so this point should be around there, and this point should be there. You can check those if you want, but by symmetry that should work. And I didn't do that curve as well. Should be a smoother curve. But you get the idea. There you go. That is your rational functions. Quite a bit of work to graph them, but if you follow the steps and then use your table of values, you'll get it. Remember, it doesn't have to be exact. We just want to get kind of ballpark shapes. Good work, everyone.